Jimmy Akin's Mysterious World is brought to you by the Star Quest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give. Jimmy Akin's Mysterious World is also brought to you in part through the generous support of Aaron Vergeson Electric and Automation, making connections for life for your automation and smart home needs in North and Central Florida at aaronv.com. And by rosaryarmy.com. Have more peace. Visit rosaryarmy.com and get a free all-twine knotted rosary, downloadable audio rosaries, and more. Make them, pray them, give them away at rosaryarmy.com.
Previously on Jimmy Akin's Mysterious World.
We're talking about the scientific evidence concerning whether we're living on a young or an old Earth.
As we saw last episode, the sources of faith don't settle the young Earth, old Earth issue one way or the other, so we need to look at what the scientific evidence says. People of both schools of thought agree that the world's history involves a mix of uniformitarianism and catastrophism. There have been big catastrophes in Earth's past, and between those catastrophes, there are processes that operate in a slow, uniform manner. Sometimes there are things like catastrophic volcanic explosions or catastrophic mud flows that can create new layers or carve through them really rapidly, but we can't generalize from that to the idea that all mountains and canyons we see on Earth were created rapidly in the last few thousand years. What we need to do is find a way to directly date rock strata, and radiometric dating is one of the best ways to do that. But there are issues we need to be aware of with radiometric dating. We need to be able to estimate the initial conditions of a sample of material, that is, how many parent and daughter atoms it originally contained. We need to be able to estimate what kind of contamination it may have experienced in its history, and we need to be able to estimate the rate of radioactive decay for the atoms in the sample. We currently have really good estimates for the rates of radioactive decay, but these rates would be different in the past if the constants of nature had changed significantly. Fortunately, we have ways of detecting whether constants have changed over time, and we have evidence that some of the constants, like alpha, may have changed at least slightly. Next episode, we'll be looking at whether the constants of the universe have changed in a way that points towards a young Earth or whether they point to an old one, particularly when it comes to radiometric dating and the problem of distant starlight.
You're listening to episode 121 of Jimmy Akin's Mysterious World, where we look at mysteries from the twin perspectives of faith and reason. In this episode, we're talking about what the scientific evidence has to say about whether we're living on a young Earth or an old one. I'm Dom Bettinelli, and joining me today is Jimmy Akin. Hi, Jimmy.
Howdy, Dom.
Last episode, we started looking at what the scientific evidence has to say about whether we're living on a young Earth. We looked at radiometric dating and some of the things you need to know to make it work. Mainstream scientists are convinced that it's very reliable, but young Earth supporters aren't persuaded. They challenge the mainstream perspective with arguments of their own. They claim that the rate of radioactive decay has not been constant. They also challenge the idea that the light from distant stars shows that the universe is billions of years old. Has the rate of radioactive decay changed? How significant is the issue of distant starlight? And what's Jimmy's bottom line about whether the evidence points to a young or an old Earth? That's what we'll be talking about on this episode of Jimmy Akin's Mysterious World. So, Jimmy, let's start again with thanking our patrons who requested this topic.
Yes, thank you to Joe Kolb, who requested radiometric dating, and Simon Michalik, who requested young Earth, and welcome to the explosive finale of our three-part series.
All right, so last episode, you mentioned a presentation about radiometric dating by the Australian young Earth geologist Andrew Snelling. What did he have to say?
He mentioned the three things that you need to estimate in order to do radiometric dating: what the initial conditions of parent and daughter atoms in a sample was, whether the sample has been contaminated and to what extent, and then what the rate of decay has been. He also gave a bunch of examples of proposed problems with radiometric dating. Here's one of the most dramatic examples he gave, which concerned a rock formation that formed after the explosion of Mount St. Helens in the 1980s.
There was a lava flow up there that we knew had flowed out in 1986. We actually observed when this rock formed. And so when it was sampled in 1996, it was 10 years old. And here's the results that were obtained. On a rock that had a real age of 10 years, the potassium-argon model ages varied from the whole rock from 0.35 million years. We separated different minerals and dated the minerals separately. And so in a pyroxene concentrate, we got an age up to 2.8 million years for a rock that was only 10 years old.
So we had a rock that we knew formed 10 years ago. But when they did potassium-argon dating on it, they got an overall age for the rock of 350,000 years. And when they analyzed the minerals inside the rock, they got potassium-argon ages up to 2.8 million years, even though we knew the rock to be just 10 years old.
So what would cause that?
As Dr. Snelling says,
the answer was obvious. Well, it had inherited excess argon. In other words, there was more argon in the rock than had come from radioactive decay. Where did the extra argon come from? Well, if you test the volcanic gases, primarily steam, but if you test the volcanic gases coming in a volcano, they can contain argon-40, because that's how the atmosphere gets argon-40. So in other words, when the lava cools, what's it going to do? It's going to trap in it some of these gases that are coming up in the volcano, which include argon-40. So it's actually going to inherit argon-40 when the lava forms. So if you come along and then assume that when you measure all the argon-40 in the rock, it came from radioactive decay from potassium, dong, you're going to get the wrong answer because you haven't factored in this inheritance.
So that's one of the things you need to do. You need to consider whether something like argon gas in the volcano that gave rise to the rock may be affecting the date of the rock. And mainstream scientists aren't stupid. They have ways to try to correct for factors like that. And Snelling notes that the mainstream literature acknowledges this. What we have here, thus, is not proof that radiometric dating simply doesn't work, but that you need to be careful in taking into account all the relevant factors when you do it.
Does he give other examples?
Yes, a lot of his talk is devoted to similar examples, and I have to say that I didn't find a lot of them particularly impressive. That's why I gave this one, because it's really, more dramatic. We know this thing is 10 years old. For example, he might point out that a particular sample of rock was dated by one radiometric method, let's say potassium-argon dating, to be 500 million years old, while another different technique, let's say uranium-lead dating, might indicate that same sample was 1 billion years old. Well, the difference between 500 million and 1 billion is only a factor of 2. And so knowing that, you might conclude that its age was likely between 500 million and 1 billion years old, with one of those tests being high and the other low. I mean, that's the way science works. A given test may only provide a rough estimate, and you need to make repeated tests, especially tests of different types, to narrow down the range more precisely. But notice, either way, we're talking about hundreds of millions of years, not a few thousand. As long as we consistently get numbers in the millions or more, that's going to be evidence for an old rather than a young Earth, because you can't say, oh, this piece of sandstone had extra argon in it from a volcanic eruption that it formed in, because sandstone doesn't form from volcanic eruptions. So if you consistently across a range of rock types with different methods are getting these much higher dates, that does point to an old Earth. You can dismiss an individual sample as an outlier, but not the whole raft of samples. However, I was particularly interested in a project that the Institute for Creation Research did called the Radioisotopes and the Age of the Earth Project, the RATE or RATE project. Snelling talked about how, as one part of this project, they went out to the Grand Canyon and took samples from multiple different layers, starting at the top of the canyon and going further down and thus further back in time. They then sent these samples to mainstream laboratories for radiometric dating, and it was important to use mainstream labs so that people couldn't accuse them of cooking the results. They also used multiple different methods to test the age of the rocks, so this should be a really good test project. What I noticed as he presented the results of this sequence of Grand Canyon strata datings was that although the different methods came back with different results, they were all fairly close to each other. The results in the first or topmost layer were all within a factor of 2 of each other. The results on the second or next layer down were all within a factor of 3. The results on the third layer down were even closer, with everything within a factor of 0.5 or 1/2 of each other. And the results on the fourth layer down were the closest yet. They were all within a factor of 0.3 or 1/3 of each other. I also, of course, noticed they're all in the millions of years. And I noticed that they kept increasing. So the deeper in the canyon wall you went, the further back in time the dates were. And if nothing else, that would let you establish the relative dates of the rock strata.
What do you mean by relative dates?
Chronologists distinguish between 2 types of dating, which are known as relative and absolute dating. An object or event has a relative date if it's being measured relative to another object or event. By contrast, it has an absolute date if it's being measured against an absolute timescale. For example, suppose we've got 2 brothers, Ben and Bob, and Ben was born in 1970 while Bob was born in 1975. I would be giving a relative date if I said Ben is older than Bob, but didn't mention any birth years. Same thing if I said Ben was born first. That's a relative date. I'm telling you how old Ben is relative to Bob, a relative date. But if I say Ben was born in 1970, or if I say Bob was born in 1975, I'm bringing in an absolute dating scale, and so I'm giving you an absolute date.
Does giving an absolute date mean you're giving a precise one?
No, and this comes up all the time when doing chronological or geological chronologies. Often we don't know exact absolute dates, but we can give approximate absolute dates. For example, if I say the Gospel of Mark was written before the Gospel of Matthew, I'm giving you a relative date for Mark. But if I say the Gospel of Mark was written in the 1st century, I am giving you an absolute date, the 1st century. Yet I'm not giving you an exact date within that century. At least based on what I said, it could have been any time in the 1st century, so it's not exact, even though it is absolute, because I'm measuring it against an absolute timeline, which is the sequence of numbered centuries. The bottom line is that we don't want to confuse absolute dates with exact dates. We can still give absolute dates, even if they're only approximate.
If radiometric dating shows that the layers in the Grand Canyon give progressively older dates the further down you go, that would suggest that they have progressively older relative dates, correct?
Yeah, and even if you don't buy the absolute dates that the tests suggest in the millions of years, you still see this pattern of increasing relative dates. As you go deeper in the layers in the Grand Canyon, radiometric dating correctly shows the relative dates of the rocks, so you can say this layer is older than this other layer. And Dr. Snelling agrees with that. Even though he disputes the absolute dates of these strata as a young Earth supporter, he acknowledges that you can use radiometric dating to establish relative dates.
Implications, however, come from out of this. And stay with me. The resultant millions of years ages, though unreliable and highly inflated compared to the biblical timescale frame, can still give us a relative order of relative ages in the rock units data. They still match the relative order. You know, all those samples from the Grand Canyon come from what we call the Precambrian, and they all yielded Precambrian ages. In other words, they match, well, that's because the timescale was built from radioactive ages, but you still hit the target in terms of where in the geologic column the samples come from. And so that gives you a clue that even though the absolute ages are wrong, you can still use the methodology. When you have an unknown rock, you can test it for radioactive decay ages, and that will help you give a relative age of where it fits in the geologic column or where it fits in the order of Earth history from a biblical perspective. So here on this graph, we can see that many of the accepted radioisotope ages do, in fact, match the relative order of the strata. Here's where they match along this line here. You've got lots of outliers, sure, but you've got a lot that match.
So Snelling acknowledges that there may be outlier measurements and that they're not what's important. Outliers happen in science. What's important is the overall pattern, and he recognizes that there is a pattern that will allow you to use radiometric dating to measure at least the relative age of rocks. He even says this.
The point is I want to make is we don't have to fear radiometric dating as a foe, but rather treat it as a friend, albeit as a tool to provide relative, not absolute ages.
And this is a very significant admission. Even though he doesn't think it should be used for establishing absolute dates, Dr. Snelling and others at the Institute for Creation Research acknowledge that radiometric dating is reliable enough to determine the overall sequence for the ages of rocks and thus provide them with relative dates with respect to each other.
Why doesn't he think that radiometric dating also gives us at least approximate absolute ages?
There's only one way to say that radiometric dating works well enough to give you relative dates, but not absolute ones. That way is to say the rate of radioactive decay has changed, and not just changed a little, but changed dramatically over the course of time. The primary reason he thinks it's changed is because he believes that the Bible requires the earth to be only a few thousand years old. He also attributes a theological motive to those who believe that the rate of radioactive decay hasn't changed or changed dramatically over time. He says that mainstream scientists hold that the rate of radioactive decay has been constant because they want to avoid the idea that the Earth is young, and so there hasn't been time for evolution.
It is insisted that assumption number 3, constant decay rates, is universally true in the conventional literature. That's the sacrosanct assumption. Why? Because the resultant ages give us the millions of years that are needed for evolution to be true. That's why this age issue matters. As soon as you show that the age of the Earth is young, then there's no time for evolution. And the Bible has to be true, and there has to be a creator, and therefore we're all sinners in need of repentance. That's what they fight against. It's ultimately a spiritual issue, this time question.
Is it true that people are saying the rate of radioactive decay has remained the same so that they can deny the idea of God and the need to repent?
Oh, for some people, sure. You can find people who believe any proposition you want for all kinds of reasons. That's why I don't like psychologizing other people's arguments and focusing on their motives. It's a form of ad hominem argument. I prefer to look at the evidence that they offer instead and only look at motives if necessary. And even though some may insist that the rate of radioactive decay hasn't changed because they want to avoid the idea of God and our need to repent, that's clearly not the case with everyone. Not every non-Christian scientist has that motive. And not every Christian scientist does either, because there are Christian scientists who are perfectly convinced of the existence of God and of our need to repent, and yet they also believe that the rate of radioactive decay hasn't changed, or at least not dramatically. Remember, as we saw last episode in the case of alpha, there can be ways to check whether the proposed constant has changed over time and by how much. Coming up, we'll be looking at a piece by a scientist who's a Christian who makes this exact point with regard to radioactive decay. Whether the rate has changed or not will have effects that should be measurable today.
Last episode, you mentioned a difference between the ideas of uniformitarianism and catastrophism, and said that both young Earth and old Earth supporters believe the world got the way it is through a mix of slow, uniform processes and catastrophic changes. Does the idea of an accelerated radioactive decay fit into that?
Yeah, one of the things I noted is that the mainstream scientific community believes in physical catastrophes, like when asteroids smack into Earth and kill dinosaurs and stuff. However, they aren't catastrophists when it comes to the laws of physics. They think that the laws of physics either haven't changed or very much in the past. But young Earth supporters frequently do. Many are what you might call physics catastrophists because they think the laws of physics were radically different in the past. And they often think that the laws may have radically changed at more than one point in the past. In fact, that's the case with the rate of radioactive decay. This is an aspect of what Dr. Snelling and other contributors to the RATE project believe about the way the rate of radioactive decay has changed. They don't think that it was only different before the creation of man. They do think it was dramatically higher then. Specifically, they think that radioactive isotopes decayed at like 1 billion times faster than they do now on the first 3 days of creation. But that's not the only time this happened. In order to use Noah's flood as an explanation for how a lot of geological formations like the Grand Canyon came to be, they need a second period of dramatically greater radioactive decay. And so they also propose that isotopes decayed approximately 1 billion times faster than they do now during the year of the Great Flood. That's why the layers of rock in the walls of the Grand Canyon can have radiometric dates in the million-year range and yet only be a few thousand years old. It's because they underwent the equivalent of 1 billion years of radioactive decay in a single 12-month period. But since the strata that make up the walls of the Grand Canyon are supposed to have been formed during that year in layers that have different dates, this produces something really interesting from Dr. Snelling's perspective. To understand this, remember the distinction between parent atoms and daughter atoms. In radiometric dating, parents are the atoms that have not yet experienced radioactive decay, while daughters are atoms that have. For example, in carbon dating, parent atoms of carbon-14 decay into daughter atoms of nitrogen. The number of parents and daughters tells you how long it's been since a sample was formed, assuming that nothing else has changed, like the amount of contamination or the rate of radioactive decay. Here's Dr. Snelling's proposal.
If radioactive decay was grossly accelerated during the flood, then even though the ages are inflated, they should yield relative ages in the correct order. Why? Well, a lava that was erupted in the first month of the flood, during the flood would go 12 months, a year of accumulation of daughters at an accelerated rate. Whereas a lava flow that erupted in the last month of the flood would only accumulate 1 month's worth of accelerated daughter products. So when you date these rocks, this rock should give an older age because it's had 12 months worth of rapidly accumulated daughters, and this one should give a younger age because it's only got 1 month worth of rapidly accumulated daughters.
Thus, if this hypothesis is true, you could in principle determine which month in the year of the flood, the individual layers in the Grand Canyon were laid down. You know, this layer was in March, and this one was in April, and this one was in May, and so on. And that's a really cool idea. I'd love to be able to radiometrically date the exact month a rock was formed. But the idea depends on there having been a sudden year-long billion-fold increase in the rate of radioactive decay. I also realized there was a problem with the proposal Dr. Snelling made about dating the rocks to different months in the year of the flood. If the constants of the universe were different, so that radioactive decay was happening a billion times faster, that wouldn't just apply to the rocks as they formed on the surface. It would also apply to the magma that was still inside the Earth. For example, if there's a potassium atom or a uranium atom in the magma that will eventually become a rock, it should have still been subject to a billion times greater chance of decaying, whether it was above or below the surface. And we'd still see the resulting daughter atom in the eventual rock. So late in the year of the flood, when the lava flowed out to form the upper rock layers in the Grand Canyon, it should have already undergone months of billion times greater radioactive decay under the surface before it flowed out. That means that when the rocks formed from the cooling lava, they should have appeared to be the same age as rocks formed earlier or later in the same year. It wouldn't matter whether the radioactive decay happened to the material before or after it got to the surface. If the laws that govern the universe were different, the rate of decay would have been the same, and the rocks that formed at different times in the same year would appear to be the same age.
Is there a way to avoid that conclusion?
You'd need to say that it wasn't simply a change in the constants of physics that govern radioactive decay. You'd need to say that there was a different rate of radioactive decay on the surface than there was under the Earth's surface. So the constants would have to be different depending on whether you're above or below ground. Of course, an omnipotent God could do a special miracle that made this happen, but at that point, you're positing extra miracles that change the constants of the universe a few feet above or below the Earth's surface. Otherwise, the material should look the same age because the same decay would have occurred one place or the other. That means, by positing these extra miracles, that you're departing from what the scientific evidence would suggest in an even more dramatic way. You're already departing from what the scientific evidence would suggest if you propose there was a sudden billion-fold increase in the rate of radioactive decay that lasted for 1 year and then shut off. It's even more of a departure if you propose that this billion-fold increase happened only above the surface of the Earth and not below it. At that point, it gets even harder to claim that the scientific evidence supports your view. But whether or not you follow Dr. Snelling's proposal about dating rock layers within the flood, you definitely need at least these two billion-fold increases in the rate of radioactive decay, one in the first few days of creation and another during the flood.
Let's take a step back and talk about the RATE project itself. Can you give us more information about it?
As we indicated, it was a study done by the Institute for Creation Research, or ICR, which is the most famous young Earth organization. They started it, the RATE project, in 1997, and they published their results in 2 volumes, which came out in the year 2000 and also 2005. They did not go just to the Grand Canyon. They went to a bunch of places and tried to collect a lot of data. In 2007, the American Scientific Affiliation published a review of the RATE project findings. Now, the American Scientific Affiliation is a Christian organization whose statement of faith includes the Nicene and Apostles' Creeds, as well as an affirmation of the inspiration, trustworthiness, and authority of the Bible. So they're not a bunch of secular atheists. They're on fundamentally the same team as the ICR in that they're all Bible-believing Christians. The review was done by Dr. Randy Isaac, who has a PhD in physics, and he provided a summary of the key points of the book. According to his review of the ICR's rate project, its key findings and claims were:
1. There is overwhelming evidence of more than 500 million years worth of radioactive decay. 2. Biblical interpretation and some scientific studies indicate a young Earth. 3. Therefore, radioactive decay must have been accelerated by approximately a factor of 1 billion during the first 3 days of creation and during the flood. 4. The concept of accelerated decay leads to 2 unresolved scientific problems: the heat problem and the radiation problem, though there is confidence that these will be solved in the future. 5. Therefore, the rate project provides encouragement regarding the reliability of the Bible.
Dr. Isaac then goes through individual points from the book, but even though the review is an excellent read, we don't have time in this episode to go through everything he covers. We will have a link to it, though, so you can read it for yourself and his critique of the rate project. A key thing to note, and he points this out, is that the rate project authors acknowledge that, quote, there is overwhelming evidence of more than 500 million years worth of radioactive decay, close quote. Now, that's at today's rate. They're acknowledging that much radioactive decay at today's rate. We've got overwhelming evidence for that in the rocks that they analyzed. That's extremely significant, and the question is whether today's rates, or ones approximating them, also applied in the past. If they did, then the Earth is more than 500 million years old. Since the rate project authors don't believe that, they therefore propose that there were 2 very short periods in which radioactive decay rates jumped by a factor of 1 billion. But, as we talked about last episode, number 120, scientists have ways to detect even tiny ancient changes in the constants like the fine structure constant, or alpha. And the same thing applies here. If the rate of radioactive decay was 1 billion times higher in these periods, that would have effects on the world so that we should be able to check whether there was such a dramatic variation or not.
How would a billion-fold jump in the radioactive decay have changed things?
Some of what I'm about to cover comes from Dr. Isaac, and some of it are things that occurred to me. When radioactive decay happens, it takes one of a number of forms, depending on the isotope in question. Some isotopes release alpha particles, which are essentially the core of a helium atom with 2 protons and 2 neutrons. Others release beta particles, which are electrons or positrons. Others release gamma particles, which are high-energy photons. And still others release neutrons. Whatever type of isotopic radiation is involved, they release something, because that's what this type of radiation is. It's when atoms release or radiate a particle. When these particles are released, they interact with the atoms near them to cause various effects. One such effect is heat, which is why nuclear bombs and nuclear reactors generate heat. Another can be a kinetic blast, like when the neutrons emitted by uranium atoms cause an uncontrolled chain reaction and make a nuclear bomb explode. And if there are nearby life forms, they can be blown apart by the kinetic blast, burned alive by the heat, which is a special kind of kinetic energy, suffer genetic damage to their DNA, or die from radiation poisoning.
So what would it mean if the rate of radioactive decay suddenly accelerated by a factor of 1 billion?
As we saw last episode, raising alpha by 4% would kind of wreck the world. Well, so would raising the rate of radioactive decay by a factor of 1 billion. Even before man, on the first 3 days of creation, some of the uranium deposits in the Earth's crust should have gone critical, just like at the Oklo nuclear reactor. And some of them should have gone prompt supercritical, resulting in nuclear explosions from uranium deposits in the soil that became not just natural nuclear reactors, but natural nuclear bombs. that should have shattered and vaporized the rocks that contained the uranium. So if we have a uranium-laden rock that seems to date from before the flood, we'd want to ask why it didn't melt or blow up. Also, according to Genesis 1, plants were created on day 3 during one of the periods of accelerated decay. You'd think that some of the plants would have been blown up, burned, or killed by radiation poisoning, or drastically mutated by the accelerated nuclear decay of uranium or any other radioactive isotope. But to get around that, you could propose that maybe the plants weren't created until the end of the 3rd day, so when the decay rate had settled down, and so this might not be a worry. The real worry comes when we hit the billion-fold radiation spike that happened during the flood. First, if you're changing the constants of nature that govern radioactive decay, I'd really like to know what effect that's going to have on the nuclear reactions happening in the sun and other stars, which all existed now that we're in the flood and thus past day 4 of creation week. What happens to all those fusion processes that keep the star going and stop it from either collapsing or going nova? But I haven't seen calculations on that, so setting that aside and looking just at Earth, we again would expect deposits of uranium-235 and other isotopes to be going off like nuclear bombs, or at least becoming nuclear reactors, during the flood. So where's the evidence for that happening? We could detect the Oklo reactor. Why aren't we seeing a lot more wherever we see a uranium deposit today? More to the point, why weren't Noah, his family, and the animals in the ark all killed? Why weren't they blasted, burned, killed by radiation poisoning, or horribly mutated? And what about all the fish in the sea? Because the same thing would have been happening to them. Why didn't the seas boil? Worse, why didn't the crust of the earth boil? We should be talking about a global disaster that was much worse than just a flood. In fact, Dr. Isaac states,
thermal energy from radioactive processes is a major source of heat in the Earth. If those processes were accelerated by many orders of magnitude, the Earth would have quickly evaporated from the heat.
So, the Earth itself should have evaporated.
What do the rate authors have to say about this?
They propose that there was some unknown method of cooling that kept this from happening. Now, notice, that doesn't solve all of the problems that we would be facing, like all of the natural atomic bombs going off, or the radiation poisoning, or the genetic mutations, or the kinetic blasts, but at least it would solve the heat issue if there's this unknown cooling process. But there are new problems. First, how did this cooling work? The rate authors do not have a definite solution to propose. They speculate that it might happen due to the expansion of the universe, which could dilute heat as the universe grows in size. But this wouldn't affect heat concentrated in matter that is here on Earth. Heat is the small-scale kinetic vibration of matter, and when space around Earth expands, that doesn't change the rate at which matter here on Earth is vibrating. Certainly not in the short term. And this is also only a speculation. The rate authors don't claim to have solved the heat problem. They only express a hope that it will be solved in the future. Second, if some unknown process suddenly shows up here on Earth to decrease the temperature of the Earth's crust so that it doesn't turn molten or evaporate, that cooling process is going to have its own consequences. Among other consequences, it would be enough cooling to freeze the oceans and Noah's family and the animals. I mean, suppose you had a freezer in your kitchen that is so powerful it will instantly turn molten rock solid just by its cooling power, which is what you would need to keep the Earth's crust from melting. Well, since the melting point of rock is higher than the melting point of water, such a super powerful freezer would also freeze any water that you put in it. And since flesh is mostly made of water, it would also freeze any meat that you put in it. So why didn't the oceans freeze? Why didn't Noah's family and all the animals, including the fish in the sea, turn into corpsicles due to the supercooling factor that was keeping Earth's crust from melting?
Would there be ways around these problems?
Again, an omnipotent God can do whatever he chooses, so he could have made localized exceptions to protect Noah and all the fish in the sea. I mean, he could put a little bubble of protection around every individual fish. But at that point, we're piling on the miracles. There's nothing wrong with miracles, but I mean, they do happen. But the more unverifiable miracles you propose to make the scientific data fit your interpretation of the Bible, the more you make it hard to claim that the scientific evidence points to your position. What it really looks like is the scientific evidence does not support the young Earth position, and young Earth supporters are proposing a series of miracles to explain away what the scientific evidence suggests.
What can we say about the rate study overall?
It's commendable that the Institute for Creation Research would undertake a study of this nature, including the facts that they would incorporate multiple data points and multiple testing methods, as well as submitting their samples to mainstream labs to show that they didn't predetermine the results. It's commendable when they acknowledge that radiometric dating is reliable enough to determine the relative ages of rocks, even if they don't think it's possible to determine absolute dates. It's also remarkable and commendable that they would acknowledge that the samples that they submitted showed overwhelming evidence of having been subject to more than 500 million years of decay at current rates. However, the creation science that they practice loses the science part when they start proposing that there were sudden changes in the laws of nature that involved billion-fold accelerations of radioactive decay for short periods of time, like 3 days or a year. You can simply say, well, God did it, but it's not science telling you that. It's prior theological commitments. Further, these billion-fold increases should have had dramatic effects on the Earth, such as creating innumerable natural nuclear bombs, releasing so much heat that the Earth vaporized or at least turned molten, and either through kinetic blasts, heat, or radiation poisoning, made it uninhabitable to all life forms, including Noah's family and the animals and all the fish in the sea. Adding additional miracles to account for why all of them survived unharmed is possible. One such miracle would need to involve a supernatural cooling factor that kept the Earth from vaporizing while simultaneously not freezing the oceans and Noah's family and all of the animals, including the fish. You'd also need to miraculously protect all the life forms from the billion years worth of radiation that was released in a single year, which should have done drastic genetic damage and frankly killed them. But once again, you can miraculously protect them, but we're multiplying miracles instead of following the scientific evidence where it points. So even granting that it was literally true that there was a global flood, that one man and a stock of animals, or one family and a stock of animals, survived on a boat, the scientific evidence that we have does not suggest an accelerated rate of radioactive decay. Their mere survival points to a rate of radioactive decay like the one we see today. And that points to the Earth being old, so that the timescale proposed by radiometric dating is not only useful for determining relative dates, but also absolute dates, which are in the millions and billions of years. Thus, even though you can use miracles to explain it away, the scientific evidence points to us living on an old Earth rather than a young one.
Okay, let's take a moment to thank our patrons who make this show possible, including Michael H., Dominic M., Martin C., Vicky W., and Gerardo E. Their generous donations at sqpn.com/give make it possible for us to continue Jimmy Akin's Mysterious World and all the shows at StarQuest, You can join them by visiting sqpn.com/give. Jimmy Akin's Mysterious World is also brought to you in part through the generous support of Aaron Vergeson Electric and Automation, making connections for life for your automation and smart home needs in North and Central Florida at aaronv.com. And by rosaryarmy.com. Have more peace. Visit rosaryarmy.com and get a free all-twine knotted rosary, downloadable audio rosaries, and more. Make them, pray them, give them away at rosaryarmy.com. So, Jimmy, you said we'd also be looking at another issue besides radiometric dating. How do you want to get into that?
By asking the listeners to contemplate a question. Wouldn't it be awesome if scientists invented a device that would let you directly view events in the past with your own eyes?
Doctor, what is this machine? It's quite simple. It just means that anything that ever happened anywhere in the universe is recorded.
I couldn't have put it better myself, child.
That meant that you could just tune in and see any event in history.
Do you mean a sort of time television?
Yes, like that.
Yes, that's exactly what this is.
Only time television is such a 1960s name, so I'm going to propose we call it something else. The device that lets you see the past with your own eyes will be called the Magic Time Window. And the good news is scientists have invented it. The time window really exists. In fact, they invented it 400 years ago, so the technology has had a chance to mature. Only they missed a really great marketing opportunity because instead of the awesome name Time Window, they gave it the much more boring name Telescope. But Time Window is so much more fun. And it really does let you view events in the past because light has a finite speed and it takes time to reach you. In fact, whenever you see anything, even just what someone is doing across the room, you're viewing something that took place at least a tiny fraction of a second earlier. And when you look further away, you're seeing events further back in time. For example, when Galileo pointed his time window at Jupiter, he saw 4 of its moons, the ones big enough for him to see, moving around the planet in their orbits. But Jupiter is an average of 44 light minutes from Earth. So he was actually seeing where those moons were 3/4 of an hour ago. And he was seeing Jupiter where it was 3/4 of an hour ago in its orbit. A few years ago, I wrote a blog post where I talked about this, and I included a picture that scientists took of a star back in the year 2008. It's a really cool picture, and you can see not only the star, but 3 of its planets in their orbit. So this is one of those modern, highly resolved pictures where you can see both a star and its planets. And we can see 3 of them here. And since the star was 129 light years away, that meant the image showed where the planets were 129 years ago in the year 1879. So we have an image, a picture of the past of events that were taking place in the year that the apparition at Knock, Ireland took place, and that the California Constitution was ratified, and that Thomas Edison unveiled incandescent light to the public. It's a genuine photograph of the past. But we can keep going even further out and further back in time. Also, in 2008, scientists took another picture, which I also have on the blog, of a supernova happening in a galaxy 88 million light years away. It's even a time-lapse picture, and you can see the supernova going bang really clearly in X-ray light. So here we have what's a little motion picture. It's an animated GIF or GIF, however you want to say it. No need to kill each other about that. It's a little motion picture of an event as it took place 88 million years ago, back when dinosaurs were roaming the earth in the middle of the Cretaceous era. It's an actual movie of an event happening in the Cretaceous era. I mean, that's awesome.
So how do young Earth supporters handle things like this?
In different ways, and this is what's known as the distant starlight problem, or just the starlight problem in young Earth, old Earth discussions. The question is, how can images of events happening millions or billions of light years away get to us in just a few thousand years. One proposal is that the images are fake and that God created the starlight already on its way to the Earth, so it's really only traveled a few thousand light years, and it doesn't show what was happening millions of years ago in the distant past because that past didn't exist. One argument for why God would do this is because he wanted to create a universe with the appearance of age or maturity. Supporters of this idea argue that God created Adam and Eve as adults rather than babies, so he gave them maturity from the start, and in the same way, he may have given other aspects of the world maturity or the appearance of age.
What do you make of this argument?
I've never been impressed by it. Even if you don't buy evolution and you think God directly created Adam from the ground and Eve directly from his side, there's a good reason why he would make them as adults. Babies can't take care of themselves. So if there was no community of near humans to take care of baby Adam and baby Eve as they grew up, God would either need to run his own divine daycare service or create them in a form where they were old enough to take care of themselves. So there would be a reason for him to create humans with maturity. But there would seem to be no reason for him to do the same thing for other aspects of the world, like showing us an imaginary video in the year 2008 of a star blowing up 88 million years ago in a past that never happened. That doesn't make any sense, and it would seem that God would be lying to us by showing us images of a purely fictional history. And many in the young Earth community are sensitive to this. They recognize that the idea of God showing us a fictional history that we can see with our own eyes is inconsistent with him being the way, the truth, and the life, because that wouldn't be the truth. Consequently, the idea that God created Starlight in transit has fallen out of favor in the young Earth community and isn't as popular as it used to be.
How else have young Earth supporters sought to solve the starlight problem?
Another theory, which was popular for a time, was known as C decay. That's C as in the speed of light from Einstein's E equals mc squared equation. The idea was that C, or the speed of light, decayed over time. So it used to be much, much faster in the past and has progressively gotten slower. Originally, perhaps in the first few days of creation, the speed of light was millions or billions of times faster, allowing light from objects billions of light years away to get close enough to Earth that it can be arriving today. In that case, the supernova that blew up really is 88 million light years away and really did go bang, so we're seeing a real event. It's just that the speed of light used to be a lot faster, and so it wasn't as long ago as it appears. The star may be 88 million light years away, but the supernova only took place a few thousand years ago, and the light got here in that time because it used to be much faster than it is now.
This is another proposal where a constant of nature was different in the past. Would we see differences in the universe if the speed of light used to be a lot faster?
Most definitely. Just think about Einstein's equation E equals mc squared. That means energy equals mass times the speed of light squared. Well, 1 million squared is a million times a million, or 1 trillion. So if you jack up the speed of light by a factor of millions, you're jacking up the energy level of the universe by a factor of trillions. And, that's going to be noticeable. There will be observable effects if the energy level of the universe was different when light was leaving distant stars. And notice that the C decay theory doesn't involve a one-time higher speed that then immediately fell to the present level, or even a few times, like we talked about with radioactive decay. Since the stars are at different distances, some are thousands, some are millions, some are billions of light years away, for their light to be arriving now, the speed of light would have had to be constantly dropping throughout history. And CDK supporters even proposed a steadily dropping curve to show how the speed of light would have changed over time to fit the needed starlight data. Thus, when our sun was created on day 4 of creation week, it would have been vastly more energetic than it is now due to the higher speed of light. According to some calculations, it would have been 800 million times stronger, in which case Adam and Eve would have been burned to a crisp and the Earth would have evaporated immediately. There are other problems with the CDK theory, but we don't need to go into them because suffice it to say that young Earth supporters have generally abandoned the CDK theory as a result of these problems being pointed out. So it's not a popular theory these days, at least with the creationist think tanks.
So what is their current explanation?
There doesn't seem to be a consensus. If you look on the website for the Institute for Creation Research, they have a page that mentions a couple of proposals. One has to do with stretching space due to high gravity. So that's how light got here quicker. It's because space has been stretched because of high gravity. But high gravity creates its own observational effects. You know, that's how we get black holes and stuff. Another proposal has to do with the idea that the speed of light might be different depending on whether the light is traveling to or from Earth. To measure the speed of light, we can do things like bounce radio waves off the moon and measure how long it takes for the waves to bounce back to us. When we do that, we find it takes 2.6 seconds for us to hear the radio waves bounce back. And so we know the moon is 1.3 light seconds away, allowing 1.3 seconds of travel time for the radio waves to get to the moon, and then another 1.3 seconds for them to get back to us. Since we know how far the moon away is in miles, we can then use that to figure out the speed of light in miles per second, which happens to be 186,000 miles per second. So let's just call it 200,000 miles a second. Well, some young Earth supporters have proposed that you could achieve the same effect if the speed of light works differently, depending on whether the light is coming from Earth or toward Earth. Suppose that light leaving Earth is only half as fast as we think it is, but it has infinite speed if it's approaching Earth. In that case, the radio waves would take 2.6 seconds to reach the moon and then no time at all to bounce back. We would thus get the appearance of light traveling 186,000 or roughly 200,000 miles per second, even though it's really only traveling 93,000 or about 100,000 miles per second when leaving Earth, and then infinite miles per second when coming back. This would allow light from distant stars to reach us instantaneously all the time. And so that 2008 explosion of the distant supernova 88 million light years away didn't take place in the past on this theory. It took place in 2008, and the light reached us instantly.
Wouldn't this also require the Earth to be the center of the universe?
It certainly would be easier, maybe, but not technically required because an omnipotent God could just make the Earth a special point with respect to the speed of light, irrespective of where the physical center of the universe might be.
Okay. But in general, what do you make of this proposal?
Personally, I find it very implausible that light works this way. I mean, among other things, it would mean I could play this game of radio wave ping pong with the moon, where I first release a burst of radio waves at the moon, which leave my transmitter at 100,000 miles per second. And then when they reflect off the moon and come back, their speed is suddenly infinite. And then if I use a reflector dish to send them back to the moon again, their infinite speed suddenly drops to 100,000 miles per second. And then when it switches again to infinite when they bounce off the moon. And it just keeps going like that with the infinite speed of light switching down to a finite speed and back for no apparent reason. And I just find that very implausible.
Is there a way to test this hypothesis?
Yeah, because you don't have to test the speed of light on Earth. We're going back to the moon in a few years, and we could test the speed of light there and see if it really is infinite or has some other unexpected value between different points on the moon. And we've got probes at different points in the solar system, and we can have them send messages to each other and measure how long it takes the messages to arrive, letting us know whether the speed of light is infinite when not traveling to Earth or whether it has some other unexpected value. But I'll give you my prediction right now. Such tests, and I'm sure they will be done in the next few decades once we have a permanent presence on the moon, because scientists, that's one of the things scientists will want to do, is just re-verify everything from the moon to see if anything is different. Such tests will show that the speed of light is exactly the same on the moon. It does not have an infinite speed or any other bizarre value. The experiments will show that light works exactly the way modern physics expects it to, with a constant rate of speed in a vacuum that may undergo changes due to the warping of space-time by gravity, but doesn't change, and certainly not dramatically in this way, by where it's pointed in the universe. Ultimately, on the page on the ICR website, the author doesn't propose any definite solution to the Starlight problem, and he encourages the readers to simply trust God and, quote, wait for more observations and better answers, close quote, indicating that young Earth supporters don't have good answers to the Starlight problem at this point.
So, Jimmy, what's your ultimate bottom line on this young Earth question?
I understand why young Earth supporters take the position that they do. I also respect their effort to integrate their beliefs with science, and I respect their faith and how they are being true to their understanding of what the Bible requires. However, as we saw in the first part of this series in episode 119, the Bible doesn't require us to take the position that we're living on a young Earth. The creation of the sun on day 4, when the day-night cycle was created on day 1, is a clear sign that Genesis is giving us a topical rather than a chronological account. And even though there are always anomalous results in scientific research, the balance of evidence very strongly points to the idea that we're living on an old Earth in an old universe. As we saw with radiometric dating and the Starlight problem, in order to get the scientific evidence to fit a time scale of only thousands of years, you have to propose that the laws of nature were radically different in the past, and that would have either left observable traces or outright wrecked the world. And you have to propose a series of miracles you otherwise don't have evidence for in order to explain why the world was not wrecked, like why Noah's family and the fish in the sea weren't all killed or why the earth didn't evaporate. And you have to say that laws operate in some potentially really implausible ways, like the speed of light possibly changing depending on whether it's pointed at or away from Earth. And in any event, you're explaining away the scientific data, not simply following it. Of course, God could have created the world just a few thousand years ago, but with the appearance of age and all the things we see in the fossil record, he could also have created it 5 seconds ago with the appearance of age, including all of us having false memories of a past that never happened. But both of these seem inconsistent with the idea of a loving, truth-telling God. Therefore, in my view, it's better to hold that God speaks the truth to us both through divine revelation and through the created world, allowing us to conclude with paragraph 283 of the Catechism that
the question about the origins of the world and of man has been the object of many scientific studies, which have splendidly enriched our knowledge of the age and dimensions of the cosmos, the development of life forms, and the appearance of man. These discoveries invite us to even greater admiration for the greatness of the Creator, prompting us to give him thanks for all his works and for the understanding and wisdom he gives to scholars and researchers.
And that's my bottom line.
Very good. Wow. And that brings us to the conclusion of our first three-parter, and that was a good one. So
I promised you it would be explosive.
that is an explosive finale. So, Jimmy, what further resources do we want to offer to the listeners?
We'll have a link to Michael Brooks's book, 13 Things That Don't Make Sense. Also, the pages online for the Institute for Creation Research and the Creation and Earth History Museum here in the San Diego area. Also, radiometric dating and radiocarbon dating, uniformitarianism and catastrophism, creation science, young Earth creationism, the age of the Earth, that companion piece with the 101 evidences for a young age of the Earth and the universe, together with responses from Rational Wiki, the video What Actually Happened at Mount St. Helens, also a video presentation on radiometric dating by Dr. Andrew Snelling, so you can see his full presentation. Link to the table of nuclides, so you can see how they form, the half-lives form smooth-ish curve that allows us to predict them. Also, pages on alpha, a short video on the Oklo nuclear reactor, one on natural nuclear reactors, the time variation of physical constants, variable speed of light, and also two things you really want to check out: Dr. Isaac's review of the RATE project, and also my article, Is God Telling Us Fictions About the Past?, which deals with the Starlight problem.
Very good. So today we have mysterious feedback from listeners on our recent episode on Wizard Clip. And the first bit of feedback comes from David Arcudi on YouTube, who says, finally, a ghost story. Annabelle next, please.
So Annabelle is a purportedly haunted doll that was owned by Ed and Lorraine Warren, two paranormal researchers. It's quite famous, and there have even been movies about Annabelle, though she's not as the real Annabelle is not as physically impressive as the one in the movies. The real Annabelle is like a Raggedy Ann doll, but still allegedly haunted by a spirit of someone named Annabelle. And I'm glad you liked the Wizard Clip story. We did, our very first episode was on ghosts, and it took a while for me to do another episode on ghosts because I hadn't yet hit good research materials, but I'm actively on the lookout because I want more than just a story, if at all possible. I want some way to evaluate it, so that requires substantial evidence. And I'm actively searching out such evidence. If anybody has stories that can be evaluated, that we have good evidence about, by all means, I'd love to hear about them, ghost stories or whatever, with those resources, and especially electronically available resources. But I anticipate it won't be another 2 years before we have another ghost story.
All right. Lisa sent an email. She said, I love Jimmy Akin's Mysterious World. I also really enjoy American Catholic history, and it was really cool that this episode had Father Demetrius Gallitzin. Jimmy's discussion on ghosts has really helped me. I experienced a ghost or ghosts in my house as a child, and it used to frighten me quite a bit. But through the development of my faith and listening to Jimmy, I feel I no longer have the same fear should I ever encounter ghost-type phenomena again. I especially love how this story ends in a lingering benevolent light/voice and the conversion of a whole family, which isn't the kind of scary movie stuff that played into my fears. Thank you so much.
Thank you, Lisa. Glad it helped, and glad that you're no longer being plagued by ghosts.
Jeanette writes on Facebook, though I've been listening to you on Catholic Answers for over 20 years, Jimmy, I just started listening to your Mysterious World recently. I really enjoy it. I have subscribed already and will become a patron shortly.
Awesome. Thank you so much, Jeanette.
I think this might be my favorite episode so far, maybe because of the Catholic element. I agree with your take, with a small twist. While you were describing the events, I thought it likely that they might have been caused by the suffering soul of the Irish traveler, and that the prayers and Mass at the house brought him relief. I also thought the voice was a good one. I like your proposal that it was the same soul. The only thing I'd like to propose as possible is that in addition to all that, there were also two sources, namely, that some of the destructive phenomena came from the soul in purgatory, ghost, and some from demons, or a demon. That would explain why most, but not all, negative phenomena greatly diminished, but some came back and were finally driven away by the exorcism and perhaps additional prayers or priest visits.
And that's possible. As we mentioned, the options that I proposed for what might have been going on were not exhaustive, and so it is possible that it could have been a ghost and a demon, and that their activities were ameliorated by different things, and their activity may have overlapped. The ghost may initially have had some destructive things for purposes of waking the Livingstons up to their need to address the issue, and a demon also could have been involved. I suspect that the way the supernatural world works is more complex than we would suspect, and maybe more complex than we can even understand right now. So there could be, under God's providence, multiple things intertwining in different ways.
All right, Nana Gaga 2001 on YouTube writes, oddly, the thing I found the weirdest about this story is that the family took in this boarder and never asked him his name.
I suspect that they did ask him his name, or at least his last name. I mean, people back then tended to be more formal, and they'd say, my name is Mr. Whatever. So I suspect they did know his name at one time, but it didn't implant firmly enough in their memory, and it got forgotten over the course of time.
And people didn't carry wallets with driver's licenses in them in the 18th century.
Yeah.
Patrick Peters writes on YouTube, my question to the hosts and others would be, why do you think this kind of thing doesn't happen more often? Why isn't communication from the souls of purgatory a typical thing? Couldn't or shouldn't souls be more willing to let us know they want our prayers? Any idea why the Livingstons would be chosen in particular?
I think the Livingstons were chosen in particular because they didn't heed the traveler's request to get a priest to hear his dying confession. So I think that's, we can answer that part of the question. In terms of why it doesn't happen more often, well, we could always wish for more information than we have, but some people would say this is quite common, that this happens a lot and it just doesn't get reported. Not necessarily manifestations this dramatic, but at least departed souls in some way communicating with us, and either we don't understand what they're asking for because of the secularization in our culture. Back in the Middle Ages, if you had ghostly phenomena going on, one of the first things you would think is, maybe it's a soul in purgatory who needs prayer. Today, you have ghostly phenomena happening in someone's house, and they're not even going to have an understanding of what purgatory is in many households, much less would they think, maybe it's a soul that needs my prayers. Also, other people have dreams and stuff of loved ones all the time, or sensing the presence of a loved one, and maybe the need to pray for that loved one, and it just doesn't get reported. It's like kept private within the family because of the giggle factor you're going to encounter if you start publicizing it widely.
I know of at least a handful personally, people who have reported to me that they've had experiences of contacting loved ones in purgatory in one way or another. So it's like you say, it's probably not as uncommon as you might think.
Yeah.
Okay, so that should do it for us for this time. What are your theories about the young Earth, old Earth discussion? What do you think about the problems Jimmy mentioned with the idea that radioactive decay and Starlight were accelerated by factors of millions or billions in the past? We want to hear your feedback and play it in a future episode. So let us know online by visiting sqpn.com or the Jimmy Akin's Mysterious World Facebook page. You can send an email to mysterious@sqpn.com or send a tweet to @MYS_world with the hashtag of mysterious feedback. So, Jimmy, what's our next episode going to be about?
Well, this episode we talked about the beginning of the world, so now we're going to talk about the end of the world, and specifically, or at least events much closer to the end of the world. We're going to talk about a proposed prophetic/apocalyptic event, sometimes called the warning or the illumination of conscience. And we've been getting a lot of press about that lately in some circles, so we're going to dig into that next time.
Excellent. Folks, remember to like this episode of Jimmy Akin's Mysterious World on Facebook, retweet it on Twitter, and share it widely as much as you can, and let people know about not just this episode, but all 3 episodes having to do with this, and get the word out. You can find links to Jimmy's resources from our discussion on our show notes at sqpn.com/mysterious. And remember, to help us continue to produce the podcast, please visit sqpn.com/give. Until next time, Jimmy Akin, thank you for exploring with us our mysterious world.
Thanks, Dom.
And once again, I'm Dom Bettinelli. Thank you for listening to Jimmy Akin's Mysterious World on StarQuest.
Hey, D is for dinosaur, but it's a brand new word. Invented in 1841, it means terrible lizard. Spelled D-I-N-O-S-A-U-R. Sir Richard Owen thought it up. D's for dinosaur. Most fossils are found in rocks made of sand.